In this lesson, I'm going to talk about the vertical asymptotes and holes of a rational function. So to reiterate here, a rational function is any function of this form. P of x, where P of x is a polynomial, on top of Q of x, where this also represents a polynomial. So when you have one polynomial on top of another one, you have what is called a rational function, and you have to make sure you have your restrictions. You cannot divide by 0, so Q of x cannot be equal to 0. So that's the definition of a rational function. I'm going to start off by describing to you what the vertical asymptote of a rational function is. So starting with the definition up top here, it says a vertical asymptote is a vertical line that the graph of a function approaches but it never reaches. And the vertical asymptotes of a rational function occur at the non-permissible values of the function. So let's start with this example here. It says find the vertical asymptotes of the given rational function. To find the vertical asymptotes of this function, you want to find the non-permissible values. The non-permissible values occur when the denominator is equal to 0. So set your denominator equal to 0 and solve for x. So we're solving a simple quadratic here. So one way to solve it is to factor. So we're going to set up a PSA table. Our sum is going to be -1. Our product is 2 times -3, which gives me -6. Hence, the two numbers that we're looking for here is -3 and +2. So continuing on with my factoring here, I have 2x squared. We're going to decompose the middle term here. So -3x plus 2. X minus 3, and this is all equal to 0. So continuing on with my factoring here, I'm going to group the first two terms and group the last two terms. So we're going to factor out any common factors that each of these groups may have. Looking at the first group, the common factor that I can take out is x. When I do that, I have 2x minus 3. Taking a look at the second group now, we don't actually have anything to take out. We do actually, it is a 1. So we're going to take out a 1, and we're going to have 2x minus 3 is equal to 0. So therefore, my final factored form here is going to be 2x minus 3 times x plus 1. And this is equal to 0. So to solve for x from the factored form, you're gonna take each factor and make it equal to 0. So 2x minus 3 is equal to 0, and finally x plus 1 is equal to 0. So now let's solve for x. X is equal to 3/2 in this equation, and x is equal to -1 in this equation. So these are the two vertical asymptotes. Vertical asymptotes. So they're vertical lines that the graph never touches or reaches. Okay, so and to show this type of behavior, I'm actually going to go into my calculator and show you that the graph is not defined at those 2 points. So here's the graph of the function that I set up already. I used the Zoom 6 standard and I graphed the original rational function right there. So this is the graph that I obtained. And as you can tell, it's a little funny looking, but notice what happens. There are two vertical asymptotes, one at -1, right? So there's a line that the graph never touches, and that's right at -1. And our second one is at 3/2, and 3/2 is about there. Okay, so there's two vertical asymptotes. Another way to check is to actually go into the table. Okay, so go into the table. I'm going to erase this here. Notice go to x is equal to -1. Notice right there, this is an error. That means there is no y value where x is equal to -1. In other words, the graph is not defined at that point. So there is an asymptote there. So that's how you find the vertical asymptotes of a rational function.